Okay, first question on the packet. I'm gonna try and speed through this. We're solving for the speed of the pendulum. I'm gonna start off here. Actually, speed of the pendulum is what? Well, speed is equal to v, and this is the low point it's talking about. So it's asking us what is the v at that low point. Looking at the little diagram here. Am I good? Okay, I'm good. Um, Man, I'm talking so much, bro. Okay. Looking at this diagram here, the ball is being suspended at the end of a mouseless cord, and then it's released. So we can kind of assume that it's going to travel down this path and then go up to the left. And I'm going to zoom in and I'm going to clarify the displacement of this ball is to the left. I'm going to get into why in a sec. So our first step is going to be define the system. This applies for most questions like this. Define the system. What does that mean? So when we're solving for these kind of questions, right, we are looking for things like work, we're looking for energy, and those are in reference to external forces. Whenever we move something into our system, whatever force it can apply will become an internal force. And the more internal we have, the less external we have to worry about. So in this case specifically, if our system is equal to or is the ball and Earth, the gravitational force applied by Earth is now going to be an internal force, which means we no longer have to consider it when we're doing things like work. Um, Kind of an example of like where this wouldn't show up is if you're doing a question where there's friction present and the surface is not part of the system. So if you're doing a question where it's like a ramp, if the ramp is not in the system, but the ramp is applying friction, then you would now consider friction as an external force. I think there's a question like that later on in the packet, so I'll probably get to that. But just in this scenario, just keep in mind the more things you put in the system, the easier it's going to be. And since the system, like establishing it, is required on the AP exam, I suggest you kind of just write out specifically what is in the system. So here it's going to be the ball and the earth. Um, and this kind of takes us into the next step, which is going to be our free body diagram. Let me change my color actually. That'd be easy to just kind of look at a glance. Free body diagram. So looking at the ball here, the only potential forces acting on it are Fg and force of tension. So force of gravity, force of tension. Um, and this honestly transitions pretty well into the next step as well. I'm going to do them at the same time, which is going to be solving for work. So looking at these two forces on our diagram here, we can already kind of go ahead just off first glance and say that the work on both of these is zero. Why is that? Well, the work for gravity we already know is part of the system. It's, it's Earth, so we can kind of already go ahead and give it zero. But the reason that we give tension zero can also be applied to gravity. That being, the reason why I put this displacement symbol there, I'm gonna go ahead and redraw it here, is if an object is being displaced in a certain direction and there's a force happening in that has a perpendicular relationship to this movement, that means that the force has no bearing on the displacement, if that makes sense. So what I'm saying here, right, is because this tension is going straight up and is perpendicular from the displacement, the tension has no impact on the displacement and therefore no work. You see this in questions where there's like a slope as a ramp and you have like a block going down this way. Um, the ramp will usually apply an Fn force like this. Because this is a perpendicular relationship, the work of Fn is going to be equal to zero. And that same logic is applying here, where because the tension is perpendicular to the displacement, it is applying zero work. Let me just cut that out. So because our only two sources of potential work, like work has to come from a force. And because both of our forces are like have zero work, that means our work overall is just going to be zero. So we solve for work. Um, and when you have your work is equal to zero, it means it's a conservation of energy question, right? So it's going to be work is equal to EF minus E or E final minus E initial. So over here, we're going to now solve for EF and EO. Solve. Yay. And this is kind of where I like to tie back in the system because when you're doing questions like these, it's honestly pretty easy to kind of just like glance at the diagram and know what you have to put in. But seeing expanded forms can kind of trip you up. So I'm gonna just go through it in its entirety. But looking at EF, right? E final in this instance, right? When the ball, let me readjust myself. When the readjust, sorry, the ball is at the bottom here, right? We can kind of tell that it's not experiencing any gravitational because it's at the lowest point. Like it's not going to go down any further from this line here. But there's some scenarios where like it's going to be experiencing both, right? So when you're looking at your system, you can kind of tell, well, okay, if we're looking at the ball, there's going to be kinetic energy. And if we're looking at Earth, there's going to be possibly gravitational energy. Um, but when you end up actually solving the question and you see that the ball is like at the bottom here and you just end up plugging in the zero for the height, just kind of cancel this whole part out. Same with the initial point up here. You could also consider, well, what if there is kinetic and there is mgh? Well, there is h because it's up, but because it's being suspended and not being released, it's at rest. That means the velocity is zero, which means this all cancels out. So you're basically left with your EF. Whoa, what the heck did I just do, bro? Okay, you're left with your EF being that and your MG, or sorry, your E initial being that. Um, you don't really have to write out the entire thing the way I just did. Where's the delete? Um, if you just look at the diagram, like you can tell up here it's at rest. There's obviously not going to be any kinetic over here. And then down here it's at the bottom, so it obviously can't have any gravitational. Um, but just in case you guys see like somewhere where it's like fully written out, that's why you don't really have to consider that because you're crossing it out fully. Um, that was really over explained, but you get what I'm saying, right? EF is going to be equal, or E final down here is going to be equal to 1 half mv squared minus mgh. So we're taking the energy at the bottom over here and minusing it from the energy over here. And this is going to be equal to 0, which means we can kind of scooch this on over to this side. So we're left with 1 half mv squared is equal to mg. Cool. So now we are going to be solving for V. I'm not going to change my color. I'm pretty lazy. So solving for V, what is V equal to? Um, we just have to reshuffle at this point. So we just multiply both sides by 2 to cancel it out. So we get 2mg is equal to mv squared. Cancel out your m's. I'm just gonna keep on moving down. So we are left with 2gh is equal to v squared. Divide, or sorry, square root by both sides. So we get square root of 2g is equal to v. So this is almost our final answer, but you can see they're not asking us for in terms of h, they're asking us for in terms of L. Um, and generally, if they give you this and they give you an angle, you're gonna have to use it. And so we're gonna use it right now. So in this instance here, we're just solving for h. Basically, we're solving for the height. And we can see here, well, the height of the ball is this specific portion of L. We don't, it's something, right? It's something L. Because L refers to this. And let me just go ahead and erase all this junk actually. Just make this easier. All right. So if this is L, this is something L. This is a portion of L that we're looking for. And by using the cosine of this angle here, we can solve for whatever this is and just minus that from the overall length of L. So cosine 60 is equal to 0.5, or I guess you could say 1 half. So we're saying, what is it? H is equal to L minus 1 half L, if that makes sense, right? We're just kind of saying that H is equal, or I guess I could say the height of the ball is equal to a certain amount of L. And since we know that this is half of L, it's 0.50, it means that this is 0.50 L. So erase this, that would be great. So basically, you're left with the fact that H is equal to 0.50 0 L. Because if this is h, like I'm saying here, if this is h, then this has to be half of our greater length of L, right? Because using this cosine 60, we understand that cosine 60 is 0.5, which means that this whole entire chunk is just half of L. So everything we're left with has to be the other half. So we get 0.50 L. So you plug, can I move this in any easier way? Holy bro. Oh my god. Is there like a move tool or something? I'm not paying for this. Dude. Yo, am I tweaking? Okay, there we go. If we plug in 0.50 L in for H, get 2 G 0.50 L is equal to V. Obviously 2 times 0.5 is going to be equal to 1, so 1 GL is equal to V. You don't see the 1, so you get GL is equal to V. Or sorry, square root GL. Sorry, ignore everything I just said. I totally fumbled that. Why I'm at the very end of this video, I'm not recording that. We have square root 2GH is equal to V. You plug in H, we know H is equal to 0.5L. The square root of 2G 0.5L is equal to V. And then obviously 2 times 0.5 is equal to 1, so you get square root of 1 GL is equal to V, and then you don't like keep the coefficient if it's 1, so you get square root of GL is equal to the velocity of our ball. So our answer for, can I get over there? Answer for this one is going to be A. Oh my god. Well, 11 minutes? That's not that bad. Keep this pace for other videos, I'll be fine. But yeah, overall, as you guys do the other questions, I would just say, define the system, always do that. Full bar diagram, and then figure out what your work is. Sometimes we'll get conservation questions, not always. But once you do, you are always going to slap the EF minus EO equation on there because that's basically for every question. And then from there, you just solve for your question. So in this case, you're solving for V. And make sure you get the answer in terms of the answers provided to you. If they give you information like L and this 60 degrees here, you always want to figure out how to use it because if you just give them square root 2 GH, you're going to get cooked. So